Hello and welcome to today's webinar, Improve Output and Slash Rejects by Mastering Your Cap Sealer's Features and Options. This is Mark Plantier with Enercon Industries, and we'd like to thank you for attending today's web clinic. We have a lot of ground to cover in a short amount of time, so we'll start the presentation very quickly. To let you know, all attendees today will receive access to the presentation slides and an archived recording of this presentation. You may ask questions during the webinar, and we will hold on answering the questions until the end of the webinar. If we do not have time to answer all of the questions, we will contact you via email or phone to ensure that your questions have been answered. We're fortunate today to have two industry experts on cap sealing. Jeff LaGrange, Enercon's Cap Seal Product Manager, and Ryan Schilke, Enercon's Sales Director, have more than 30 years of industry experience. They're passionate about induction cap sealing, and they enjoy sharing information to help packagers become more efficient with the induction sealing process. With that, I will turn it over to Ryan Schilke.
Good morning, and thanks for joining us today. In the next 30 minutes, we're going to talk about tried and true methods you can use to master your cap sealing process. Through using those methods, you'll improve output and reduce the number of rejects you see on your line. The topics we'll cover today include the basics of how sealing energy works, the various methods of controlling sealer output, monitoring the energy level of your sealer from the very basic to the most complex. We'll look at the options you have to enhance your quality control through inspection and detection systems. Finally, we'll wrap up our time together with a little Q&A. You can submit a question anytime by typing the question into the question box on your screen. Now that you know what we're going to cover, we'll provide you with a bit of specific knowledge that you'll gain in the next 30 minutes. As we were developing this webinar, we thought about what was most important. Why was this topic important? And as it turns out, both our sales and service teams consistently said that customers ask the question about how they can improve their productivity and slash the number of rejects. Throughout the course of the webinar, you'll have the opportunity to learn about options you may not either have considered or known about when you purchased your system. Stick around till the end, and we'll share a bit more about how you can get personal expert advice from one of our application experts on your packaging line. As is true with any other piece of equipment, the more you understand the process, the more productive your people and equipment will be. During the webinar, we'll focus on actionable tips that, in many cases, you could implement with little or no involvement. What does your induction cap sealer do? We get this question all the time, and the answer is really quite simple. The sole function of an induction cap sealer is to heat the aluminum foil layer in the seal structure. As you heat the aluminum foil layer, the polymer layer that you see at the bottom of the foil, labeled D in this picture, begins to flow. As that flow and it travels under the cap sealing system, it begins to bond or adhere to the land area of the container. It's really that simple. In fact, our customers often say it's the simplest piece of equipment to operate and maintain on their line. The keys to a successful seal, whether it's induction sealing or any other sealing process, are three things. You need to have pressure, heat, and time. The pressure in the induction cap sealing process is cap application torque. The key to pressure is consistency. While the amount of application torque is important, it's even more important to be consistent with the amount of application torque you are providing. Heat in the induction cap sealing process is generated by the cap sealer itself. Based on the application, you are able to influence heat in a couple of ways. Before you purchase a system, we consult with you to determine what is the right power level that you'll need for your system. After the system's installed, you're able to change the power output of the cap sealer to adjust to the variables on your line. The final component is time. Time in the induction cap sealing process is dictated by line speed. You're able to change your line speed simply by changing the belt speed of your conveyor. You can choose to seal at any line speed you wish. However, it's very important to note that the relationship between the sealing energy required and line speed is not linear. One example that you can have is that if your packaging line is running at 100 feet per minute and 80% output, you won't necessarily see that same linear increase. That was a 10% increase going to 110 feet at 88% won't necessarily work. It could, but not necessarily. So how do we create sealing energy? We start by taking low-frequency AC power that you get from your utility. When it comes into the cap sealer, we convert that to DC power, and then after going through a series of components, it's converted back to AC power, but this time in a high-frequency format. The next step is we couple that high-frequency AC power with one of our custom-engineered sealing heads. In the sealing head, we create a highly directed magnetic field, which in the picture in the center is illustrated by the white lines emanating from the sealing head. That is typically created in the range of 40 to 70 kilohertz. It is this directed magnetic field that efficiently heats the foil seal structure, creating a hermetic seal. So that we got a little bit of an idea of how the power is generated, how the energy is generated in your cap sealer, I want to cover a few important topics on factors that will affect the amount of energy required. The first is air gap. And as we define this, it's the distance between the sealing head and the top of the cap or foil. In the picture that you see here, we have a relatively flat cap. The foil in this case is very close to the top of the cap. This is true in most flat caps that are known as continuous thread. It gets a little further away, but is still pretty close to the top when you look at a child-resistant closure. Child-resistant closure is essentially a closure within a closure, so that foil is pushed a little bit further away. The picture on the screen now illustrates a style of dispensing closure. You're all probably familiar with a mustard bottle or another bottle like this. And you'll see by the arrows that instead of being at the top, we've now pushed the foil down a considerable distance from the cap. And where this becomes important is understanding that the strength of the induction field, the magnetic field that we're generating, dissipates with a square of the distance. So if you're, a quarter of an inch to an eighth of an inch to half an inch, you're going to have different power levels at that, and it's not a linear relationship. So for closures like this, we've developed a series of specialty sealing heads, which we'll get into more in a couple of minutes. But this is a piece that is very important to know, both as you're buying an induction sealer and if you're looking to make a product change, that this may be an impact you need to consider. One of the factors that comes up quite often is cap application torque. We'll get calls quite often where people will have sealing problems, and we'll look at, all right, is there a problem with the machine? Is everything running with the machine? All right, if that's the case, which oftentimes it tends to be, we'll start to look at the other variables. And one of the questions we'll always ask is, what's your application torque? What is the level at which you're applying your closure that it's coming out of the capper? The amount isn't necessarily important, although we do recommend you consult with your cap manufacturer on what they recommend for your size closure. But one of the most important things is that it's consistent. The other rule that you can kind of draw from this is, generally speaking, caps with less torque are going to require more energy than a cap that's more tightly torqued, given it's the same diameter closure. Other factors that can affect the sealing energy that are required are material variations. One of the first pieces that we'll talk about is bottle material changes. So it could be as drastic as your package is changing maybe from a polypropylene to a PET container. In that case, the foil liner that you're using is likely to have to change. The foil lining material is typically designed for specific plastic materials on the bottle. There are some universal materials which work great in many cases, but anytime you're considering a drastic material change from one to another, it's important that you consult with your cap supplier or liner supplier on the lining material that you're using if you're going to also need to change that. You can also have subtle bottle material changes, sometimes changing from one vendor to another or one resin supplier to another. You can have variations that change. So it's important to know when those pieces change. The land area or lip of the container is also a very important piece. This is the part of the bottle that we're sealing to. The important pieces are that it's flat and even and consistent. You don't need a real large area. You can seal to about a 1 millimeter land area without a problem. But you'll want to look to verify there are no saddles or ridges in the land area. These are particularly common at the bottle part line. Another piece you're going to want to look at is the specification for your bottle and cap. You want to make sure that those are consistently within spec. We typically recommend taking random samples and just verifying they're in spec. We have seen cases where one of the two was out of spec. The packager got a seal, but it ultimately wasn't as good of a seal as they would have liked to have seen. The final piece to look for in material variations is liner changes. Be sure to take a look at what specific lining material you're using and record that in your data. And know with each shipment of caps whether there are any liner changes. Again, like we talked about in bottles, if it's a drastic change from one lining material to another, or another thing to watch out for is any changes in thicknesses, whether that's a thickness in the overall structure or a thickness in the foil structure itself. We highly recommend taking a look at one of the webinars that we put on a while back that touched on operating windows. You'll get a more thorough understanding of how to properly set up your operating window. We're going to send you a link to this after we're done here today. Otherwise, just go out to our website and check for the webinar section, and you'll find a link to that recorded webinar. So it's time to get a little interactivity. We've got our first poll question of the day we'd like to ask. Are you certain you are using the correct sealing head for your application? It's a simple yes or no question that we're going to pose out there. It'll be open for 30 seconds. And you should see it now. All right, it looks like we've got about 85% of you in. If you got another couple seconds, we'll give you a chance to vote. And we're going to close the poll now. So to give you an idea, 47% of you said, yes, you are. However, there's 23% of you out there who aren't sure that you're using. So I think the content that we'll cover here in talking about sealing heads next is going to be quite valuable to most of the audience. So how do you know that you're using the right sealing head? I mentioned a little bit that we offer a variety of sealing heads. What I want to do is walk you through the different sealing heads that we offer. We're going to start in the top left and work clockwise through. So the sealing head that you see on the top left is what we term as our wide flat sealing head. As we illustrated in the picture below, the white arcs that you see illustrated out in each of these pictures show the pattern of the electromagnetic field that we're generating. The wide flat sealing head will typically seal closures that are 63 millimeters in diameter or larger and caps that are of relatively flat nature. Typically in these larger closures you don't have too many dispensing features, but sometimes you will. In the upper right, we show a picture of our narrow tunnel sealing head. We actually create two versions of our standard tunnels, a narrow tunnel and a wide tunnel. We use the narrow tunnel to seal closures up to 38 millimeters in diameter, often used with flat or continuous thread caps, child-resistant closures, and sometimes some dispensing closures that have the foil close to the top. Our wide tunnel coil, which is the same height profile that you see here in the picture, except a little wider, we'll use to seal up to 58 millimeter closures. The lower right picture that you see now has the fields emanating a little differently than what we've seen before. Our deep tunnel coils will emanate the field from the side to get more effective heating. You see in the picture here we've got a pretty small closure. We'll typically use a deep tunnel coil like this on a product that has a 20 millimeter closure or smaller. We'll also use these in cases like we saw in the mustard picture before, where you've got the foil a long distance from the top. The final sealing head on this screen shows a combination of our standard tunnel and our deep tunnel. So we've increased the height profile here, and this is particularly important in some of the newer style closures that you see come out. Think about the upside down products that you're seeing, maybe an upside down ketchup bottle. And those products have a little bit larger diameter closure, usually with a flip top design, and have a foil in it. So that foil is recessed quite a distance, but we have the ability here to heat both from the top and from the side. We've got one, what I'll say, special design of coil that we didn't talk about. This is another version of our flat coil, but what this does is it gives packagers the ability to seal a wide range of closure diameters. So our all-in-one universal sealing heads will seal anywhere from a 20 millimeter closure on up to a 120 millimeter closure. These are typically designed, again, like our flat coils, for relatively flat closures. We can do some dispensing features. This cap in the picture is actually a salt product, and the closure flips up and you can shake out of it. So you can get a little bit of height, and it provides great flexibility for co-packers or those of you out there who just pack a wide variety of sizes and closure styles on your line. The picture on the left shows this coil on our Super Seal series. We've had this design out for about 10 years. One of our more recent designs is shown in the right picture. And we listened to what you all were saying out there, in that you're looking for ways to have an easier setup. So instead of externally pivoting the sealing head as closure diameter increases, we're now pivoting the head internally, and we provide a positive stop and a positive location identifier for each side. It makes setup more consistent time after time and makes your line operators' jobs significantly easier and more consistent. Now that we all have a feel for how we most effectively apply the energy to your package, I'd like to introduce Jeff LaGrange, our cap sealing product manager, who will share with you how you can electrically integrate your sealer into your line.
Thanks, Ryan. If you're looking to integrate your cap sealer into your line, there are several key features you'll want to have access to, depending on your level of integration. Basic onboard controls through interactive touchscreens are available. The first thing you'll probably want to control is the sealer's output. This is the heat portion of the equation that Ryan referred to earlier. Almost hand in hand with that is deciding how you'd like to start and stop the sealer. These are the basic requirements. At the next level, you may want to have a way to monitor that the sealer is really generating the output you're asking for. Lastly, you may want to be able to monitor each individual function and fault that can occur inside your cap sealer. Here we are at our second poll question of the day. Are you confident that your operators are always using your company's predetermined cap seal power level? This is just a question to see how confident you are that your operators are doing what you tell them to do. So we'll leave this question open for about 30 seconds, and we'll see what you have to say. Okay, we're going to close the question. It looks like right around 40% of you are saying that you aren't confident that your operators are always running at the right level. Well, we've got some options that can help you increase your confidence here. We're going to talk about some different ways that you can control your output and monitor these things. The first thing we're going to talk about is your standard manual local control. Local control of the output consists of the simple interface of the up-down buttons on the front panel of the unit. These are used to adjust the percentage of the sealer up and down, obviously. This is the simplest interface, and it's perfect if you don't have the required additional hardware that you need for more sophisticated controls. This also leaves the output of the sealer largely in hands of the operator. So you should have a high level of confidence in your operators to get this one right. As we know, some operators have been known to adjust the output of sealers for, we'll say, various reasons, and local power gives them this ability. The next option is remote control of your power. On the front panel, you'll see that we refer to this as auto control to differentiate it from remote start, but this is basically remote controlling your unit. With this option, you can control the output with a 0 to 10 volt signal from your process controller. This is most beneficial when you've got a central location that you'd like to control everything with. This completely removes the power control from the front panel of the unit. The last method of controlling the output is only available on the Super Seal Touch. The Touch has the ability to store recipes in its memory. They're programmed by the customer and stored for future use. If you're running several different bottles, you simply need to qualify the bottle once, then save the settings into the recipe, which is able to be named for that particular bottle. Now, when you return to that bottle a week later, for example, you can simply call up its recipe and you're ready to go. Of course, we recommend you always run a test to verify that the settings are still valid and that nothing has changed. Our Super Seal Max and Super Seal Touch sealers have the additional capability to communicate serially with external PLCs and other controllers. We refer to this as our remote control and monitoring option. With it, you can remotely control and, you guessed it, monitor virtually everything inside the sealer. For example, not only can you control the power output and start and stop the sealer, but you can also change ejector settings, reset bottle counts, monitor individual faults, and monitor all sensor status, among other things, all remotely through your controller. This is the most advanced level of integration. It's a far cry from the up-down start-stop that we saw in the local control. Now that we've covered how you can control the output of the sealer, we need to discuss how you can be sure the sealer is actually putting out what you've asked for. The most common way to monitor the output level is with the visual indication of a stack light. Every sealer has circuitry in it that monitors the output and will send an alarm signal if the output drops below a certain level. Let's talk about this circuitry for a bit. This is a very useful feature that can be used by line integrators. How it works is that there's a threshold that is set by the user, and if the power dips or drops out, the integrator is notified. For example, if you want to run your unit at 85% and want to be alerted if the power drops below this, you can set your alarm level for 84 or 83%. Then if the power drops for any reason, you'll know right away. Now, the standard stack light is tied to this circuit and can be used and can also be ordered with an optional audible alarm to give you a beep, so you don't have to be looking straight at the stack light to know when it goes. The circuitry also provides an additional contact that can be used by a line integrator as needed, depending on your protocol. It can be used to energize a large horn or perhaps trigger a blocking arm because you don't want any bottles to go through if the sealer isn't running. Or perhaps it will even stop the conveyor, whatever's needed for your process. Our sealers also have the option to provide a 0 to 10 volt feedback that can be monitored to verify the output. This will allow line operators to completely monitor the output from a remote location. Also, as mentioned before, the remote control monitoring option can certainly provide this functionality as well. If you're monitoring the output and you get an alarm, what really does that mean? There's several reasons you can see an alarm. It can be as simple as someone pressed the stop button, or maybe a stalled bottle was detected and the sealer shut off. Either of these will cause the output to fall below that alarm threshold. An operator can manually adjust the output below the threshold. There could be a drop in the line voltage that could cause the output to drop. Now this isn't very common because our circuitry is designed to compensate for that, so that that line dip would have to be pretty severe. Lastly, there can be an internal issue inside the sealer, but due to the reliability of our units, that really is very rare. Keep in mind that on all of our sealers, as I mentioned, the alarm level is adjustable, so you can set it just about anywhere you'd like, depending on your application. We've talked quite a bit about how to control the output of the sealer. Now I'd like to quickly touch on different methods of starting and stopping your sealer to fully integrate it into your line. There's basically 3 modes of starting and stopping. We've got local, we've got remote, and we've got network. Local control is pretty simple. There are start and stop buttons on the front of every sealer, and your operator can access these at any time when the local and start-stop control is activated. This can be used in much the same way that local power control is used and has the same types of concerns. Remote start allows the integrator to supply a signal to the sealer telling it when to run and when to stop. This is beneficial if your line makes use of a central control panel. It also removes the option of starting the power supply locally. For safety reasons, you can always stop the unit locally if you need to. Of course, if you're making use of the remote control and monitoring option, you can surely use that functionality to start and stop the sealer as well. Lastly, our SuperSeal Touch has some additional functionality that can be useful. It has the ability to go into a password-protected mode. This will effectively lock out the operator, where without the password, all they can do is start and stop the unit. No more unauthorized adjustments. The SuperSeal Touch also logs any faults and can display them on the screen. This is useful if you need to troubleshoot why your sealer has stopped. It will also keep track of multiple types of bottle counts, helping you monitor the output of your line from shift to shift or from run to run. We've got several options that will help you ensure properly sealed containers. Here's Ryan to talk a little bit more about these options.
Thanks, Jeff. We're getting some great questions coming in. In fact, one that is next up on our list. Enercon's cap sealing systems offer a variety of productivity and quality control features which both inspect and detect your package to help ensure the highest quality product possible. Most of these features are available on all Enercon's lineup of SuperSeal sealers. Some, the more advanced features, are reserved for the SuperSeal Touch and SuperSeal Max, but even our base model SuperSeal systems do have quality control features built into them. So I want to first talk to you a little bit about motion detection. Obviously, on any packaging line, motion is important. We've got 3 features we'll discuss. The first is auto start. Auto start is a feature which will be placed upstream from the sealer. A sensor detects when the first bottle passes through the line, and the sealing head of the system is then energized, thus ensuring you have sealed bottles as they're going through your sealer. Second feature is on the other end of the line. It's after the sealer. Downstream of the sealer, we put a bottle backup sensor. This is used to detect any backups down the line that we may want to stop the sealer for. Solid bottle detection even adds a bit more protection in your line. One problem you want to avoid at all costs is having bottles stop under your sealer. Stalled bottle detection provides the ability to know that a bottle has stopped under your sealer. The machine will shut down and provide an alert that the system is no longer running. It may sound pretty obvious, but you can't properly seal your package without a foil inner seal in the closure. Our foil detection provides this functionality. It will detect whether there is a foil in each and every cap that is coming down the line. Likewise, this feature will also detect for missing caps. If there's no cap, there's going to be no foil on your package, so it will detect that as well. In either of these cases, when that is detected, the system sends a signal to a rejection system to kick that bottle off the line. We can add even more functionality when it comes to cap application by looking at high and cocked cap detection. When a closure is not adequately applied to the bottle or the closure is cocked on the bottle, you will not get a hermetic seal. For these, we want to detect them, and just like a missing foil or missing cap, we want to send a signal to reject that bottle off the line. So these two features, foil and cap detection as well as motion detection, can be applied in any number of ways. You can look at it simply as bottle backup. You can simply do foil detection. You can combine them and do motion and foil detection. You can simply do stalled bottle detection. Or you can combine it all together and provide what we call our full cap inspection system. The one that's right is going to depend on your application. Sometimes your capping machine may detect for foil. Sometimes it will detect for foil and a cocked cap. And you may just need motion detection. Sometimes you need it all, and that's where our cap inspection system comes into play. I mentioned that all of these features will send a signal to reject the bottle. Enercon provides an integrated ejector system that we provide, or we can provide you a signal for your own rejection system, which we're more than happy to work with designing how we need to feed our signals into your rejection system. So we're pretty close to wrapping up, but now that you've got a little bit about each of the quality control features, we'd like to get a feel for which one of these options you feel would benefit your operation the most. So last poll question of the day. All right, we're going to close the poll. I'm going to give you a feel for what your peers are looking at. 29% of you said you could use motion or foil detection. 73% said full cap inspection. 26% said container rejection. Now, you could choose more of these, so obviously that doesn't add up to 100. But we'll summarize a bit about what we talked about today and then talk about the special offer that we have for you. So today we've talked about how you can boost your productivity and slash the number of rejected products that you have coming off your line. To do that, you have to understand your sealing process. You have to understand how the sealing process fits into your packaging operation. One of the important steps is establishing an operating window. As I mentioned earlier, we'll send you a link to a webinar that goes into that topic in detail. You can take advantage of our alarm circuitry that we've built in to know when your sealer dips below your prescribed level. You've got to choose the right power control mode for your operation. This is going to vary from packager to packager, but one of these is right for you. You can also choose how you start and stop the sealer. Again, that's based on your packaging operation. You can take advantage, which it sounds like a lot of you are interested in, of an inspection system to enhance your quality control. Finally, you'll want to pair that inspection system with some sort of container rejection system to eliminate any faulty containers. So I mentioned the special offer a couple of times. If you're interested in knowing more about how you can integrate these features into your line, we'd be happy to schedule a free visit from one of our application experts. They'll come in, they'll take a look at your line, consult with you on what may be the best solution for your application. If through that you decide you want to add some accessories, we'd be happy to give you a 10% discount on anything you buy as a result of that visit. All you've got to do is simply call or email me, Ryan Schulke, and we'll get a time scheduled for you. All right, now's our time for Q&A. We've got a lot of questions coming in, but feel free to continue to ask.
All right, thanks Ryan and Jeff for a very informative presentation. We're now going to go to some of the questions that came in, and as Ryan said, you can continue to send in your questions. We'll get to as many as we have time for. First question is, someone recently purchased a Super Seal and they want to know if they can add the no seal detector.
That's a great question, and one that we get quite often. You can. That is actually one of the features that you can install with your Super Seal 75 system. Just give us a call, shoot us an email. We'd be happy to show you how that happens.
We have somebody who is using a Super Seal Junior. He wants to know if the container has to be in contact with the sealing head.
That's a great question too. For the sealer to work, does it need to be in contact with the sealing head? No, it really doesn't need to be in contact with the sealing head. However, if you want container A to, bottle 1, bottle 2, bottle 3 to all seal the same, you're going to need to put them in the same location. So it's recommended that you place them right up against the sealing head so that they are all situated the same way.
Thanks, Jeff. The next question that we have, I believe we covered, but just to confirm, do any of the sealers have the ability to detect if a cap does not have a foil liner in it and stop or alarm if such a cap is detected?
Yeah, all of our sealers, all of our production systems have that built into it. There's an accessory that you add to the system, and it will simply detect if there's a foil in the closure. For that case, we will then send the signal. That's where you could use a rejection system. Some people out there will sound a horn when there's a missing one. That's one that is, it works if you've got an operator in front of the piece of equipment, but it's sometimes a bit of a hard time figuring out which one is there. So we typically recommend rejecting the container off the line.
Another question's come in. Can you over-tighten a closure if you have a hand fill line?
Yeah, you can over-tighten a closure whether you're hand filling, whether you're hand capping, automatically capping. You can do that. Oftentimes, if it's a hand filling and hand capping operation, I don't know that we necessarily see that caps are over-tightened. What we typically see is that throughout the day, throughout a shift, the application torque is going to vary. I start out 8 o'clock in the morning tightening caps, and they're going on, and we're probably getting adequate torque. Well, you get an hour into the shift, that's going to start going down. You get 2-3 hours into the shift, that application torque seems to go down when you're hand torquing them. That's where an automated capping machine or a pneumatic chuck capper is a good investment.
We have someone who is using some very thin-walled jars and flimsy caps, and they seem to get very inconsistent seals. He's wondering if you ever use additional pressure to hold the cap down and seal.
Yes, we have used additional pressure to hold the cap down. We've got another product that we didn't mention today called our pressure belt, which will induce pressure on it. I'm concerned with the description of your product. If a thin wall container, I don't know how well an external pressure inducer will work that well on that kind of a product.
Can the Enercon induction sealer be synchronized with any capper?
I would say yes. our Super Seal Max and our Super Seal Touch have with the remote control and monitoring option, they have the ability to link up with just about anything. It'll take a little setup on the customer's end because we don't know exactly how you're going to use it, but we can put all the information inside the sealer out onto your network, and you can sync that up with your capper. You can sync it up with your Wonderwear, whatever you might be using.
All right. There's a question, and this might be, we showed a photo of a all-in-one universal sealing head angled on a packaging line, and someone wants to know, is it all right to have the induction sealer head diagonal to the flow of the bottle?
The answer to that question is, if you're using the all-in-one sealing head with our Super Seal lineup, the answer is yes. The all-in-one sealing head works in a way where we have bands of closure sizes that you run. If you're running between a 20 and a 38 millimeter closure, it's typically parallel to the conveyor. But as you start to get wider than that, you start to pivot the coil. And essentially what we're doing is we're widening the effective field. So you will see in some cases, say if you're running a 58, a 73, a 120 millimeter closure, that with that all-in-one sealing head on our Super Seal 50, 75, and 100s, that will be diagonal to the conveyor. It will not be parallel to the conveyor.
We have another question related to sealing heads, and the question is, with the same power supply, could a different sealing head produce a more efficient or allow the packager to go faster?
I would say absolutely. If you've got a Super Seal 100 and you've got a coil that maybe is not optimized for the type of cap that you're using, it may be able to seal it, but if you go ahead and get one that's really designed for that type of cap, you will definitely get higher performance and higher speeds out of that optimized coil.
Someone would like to know if it's possible to calibrate the output or possible to verify the output is the same as the number displayed.
Yes, it's definitely possible. On our Super Seal line, it's pretty easy to remove the coil, and you can put a current transformer on the output to verify that. We've also got an option or a validation package that will totally help you document that and keep track of it down the line. But you can definitely do that. We've got procedures written included in the validation package, and you can call our service department. They can definitely help you out with that.
All right, we've got time for one or two more questions. The next question is, what is the recommended clearance between the cap and the product?
That's a good question. Typically, the important piece is that it's consistent. We've got some applications that we run as low as 1/8 of an inch or 3 millimeters. There's other applications that we run in the range of, higher than that, 10 millimeters from that side. It really depends on the application. Each of the sealing heads are different. With all of our systems that we supply, we do supply a gap gauge that is set to 1/8 of an inch. So if that's the level you want to use, you can use that. If you want to use something more like 1/4 of an inch or 3/8 of an inch, just simply put a few of those together and establish that to get the right gap there. What's important is that it's consistent, and that every time you set up that is a consistent number. It is a topic that we do cover in our operating window webinar in more detail.
One final question, does the bottle cap manufacturer matter when it comes to sealing accuracy?
Typically, I'd say no. I mean, as long as you're getting a good quality cap, you've got a foil liner in that cap that matches your bottle, it doesn't matter which manufacturer you buy from. Our sealers don't discriminate from one cap supplier to another, one foil supplier to another, but the important part is quality. I mentioned earlier about the land area being flat and even and consistent, looking for any saddles or ridges in that land area. That's the important part. That flat, even, consistent surface is really what we're looking for.
Well, thank you, Ryan, and thank you, Jeff, for your time today. And I'd like to thank the audience once again for attending. If we did not get to your question, we will have one of our experts follow up with you. Again, everyone will receive a copy of this presentation as well as access to the archived recording and the operating window webinar that Ryan mentioned earlier. Remember, if you do want to take advantage of the special offer, please use Ryan's email address as you see it on the screen to contact him. Once again, Entercom would like to thank you for your time, and we look forward to seeing you at our next webinar. Thank you.